Imagine a world ruled by giants. For over 180 million years, dinosaurs were the undisputed masters of our planet. These magnificent creatures, some as tall as buildings and as heavy as trucks, roamed Earth through the Triassic, Jurassic, and Cretaceous periods. From the fearsome Tyrannosaurus rex to the gentle, long-necked Brachiosaurus, dinosaurs diversified into a stunning array of shapes and sizes, adapting to nearly every environment on Earth. Their reign represents a vast chapter in Earth's history, a time when life reached new heights of size, diversity, and dominance. The reign of the dinosaurs was a time of incredible evolutionary experimentation and adaptation. Predators like the velociraptor developed deadly speed and intelligence, while herbivores like the triceratops evolved elaborate horns and frills for defense. Flying reptiles, the pterosaurs, soared through the skies, some with wingspans rivaling modern-day aircraft. The seas, too, were teeming with life, home to massive marine reptiles like the plesiosaurus and ichthyosaurus. The age of dinosaurs was a time of grandeur, a testament to the power of evolution to shape life on our planet. However, even the most dominant empires can fall. Around 66 million years ago, the reign of the dinosaurs came to a dramatic and sudden end. The extinction of the dinosaurs is one of the most captivating mysteries in science. For millions of years, these magnificent creatures roamed the Earth, dominating the land, sea, and air. Their sudden disappearance has puzzled scientists and sparked countless debates. What could have caused such a widespread and devastating event? Theories abound, each trying to explain the cataclysmic end of an era. Over the years, scientists have proposed numerous theories, but two stand out as the most likely culprits: a massive asteroid impact and a period of intense volcanic activity. These theories have been the subject of extensive research and debate, each providing compelling evidence. The asteroid impact theory, perhaps the most widely known, points to the Chicxulub crater, a massive impact site located on the Yucatan Peninsula in Mexico. This crater is a silent witness to a catastrophic event that changed the course of life on Earth. This crater, estimated to be 180 kilometers in diameter, is believed to have been formed by an asteroid or comet roughly 10 kilometers wide that struck Earth 66 million years ago. The force of the impact was equivalent to billions of atomic bombs, releasing energy that reshaped the planet. The impact would have released an unimaginable amount of energy, triggering earthquakes, tsunamis, and wildfires on a global scale. The immediate aftermath would have been a scene of utter devastation, with the Earth shaking violently and fires raging uncontrollably. The impact would have ejected massive amounts of dust and debris into the atmosphere, blocking out the sun and plunging the planet into a period of darkness and extreme cold. This impact winter would have lasted for months, if not years, creating a hostile environment for life. This impact winter would have devastated plant life, leading to a collapse of the food chain and the extinction of countless species, including the dinosaurs. The once lush and vibrant landscapes would have turned barren and lifeless, unable to support the diverse ecosystems that once thrived. The volcanic activity theory focuses on the Deccan Traps, a massive volcanic region in India. These volcanic eruptions were not just ordinary events, they were among the most powerful and sustained in Earth's history. Around the same time as the Chicxulub impact, the Deccan Traps were spewing out enormous amounts of lava and volcanic gases, including carbon dioxide and sulfur dioxide. These eruptions would have covered vast areas with lava and released toxic gases into the atmosphere. These gases would have had a profound impact on the global climate, leading to acid rain, ocean acidification, and a long-term warming effect. The combination of these factors would have created a harsh and inhospitable environment for many forms of life. While the asteroid impact and volcanic activity theories are both supported by scientific evidence, it's likely that a combination of these factors contributed to the extinction of the dinosaurs. The interplay between these catastrophic events would have created a perfect storm, leading to one of the most significant mass extinctions in Earth's history. The fall of the dinosaurs remains a poignant reminder of the fragility of life and the ever-changing nature of our planet. The extinction of the dinosaurs marked the end of an era, but it also opened up ecological niches that allowed other creatures to thrive. This cataclysmic event, which wiped out nearly 75% of Earth's species, was both a devastating loss and a pivotal turning point in the history of life on our planet. With the reign of the giant reptiles over, mammals, who had existed alongside dinosaurs for millions of years, were presented with a unique opportunity to diversify and evolve. These small, often overlooked creatures were now poised to take center stage in the unfolding drama of life. The world, once dominated by thunderous footsteps and the shadows of colossal creatures, was changing. The landscape, scarred by the impact of the asteroid, was a desolate and challenging environment, but it was also a blank canvas for new forms of life to emerge. The immediate aftermath of the extinction event was a time of great upheaval and ecological instability. Forests were decimated, food chains were disrupted, and the climate was in flux. Yet, in this chaos there was also opportunity. The skies, once filled with pterosaurs, were now empty. The absence of these aerial giants left a void that would eventually be filled by the ancestors of modern birds and bats. The oceans, once home to massive marine reptiles, were now open to new inhabitants. This allowed for the rise of new marine species, including the early ancestors of whales and dolphins. On land, the disappearance of the dinosaurs created opportunities for smaller, more adaptable animals. These creatures, often overlooked in the shadow of the dinosaurs, now had the chance to explore new habitats and exploit new resources. Among the survivors were small, shrew-like mammals that had scurried underfoot during the age of dinosaurs. These resilient creatures were well suited to the new world, with their ability to burrow and hide from predators. These unassuming creatures possessed several key adaptations that allowed them to weather the extinction event and thrive in its aftermath. Their small size and nocturnal habits helped them avoid many of the dangers that larger animals faced. They were small and agile, able to hide from danger and exploit a wider range of food sources. This versatility was crucial in a world where food was often scarce and competition was fierce. They were warm-blooded, allowing them to maintain a stable body temperature in fluctuating environments. This physiological trait gave them an edge in surviving the harsh and unpredictable post-extinction climate, and they gave birth to live young, which increased their offspring's chances of survival in a harsh and unpredictable world. This reproductive strategy allowed for greater parental care and protection of the young. With the dinosaurs gone, these early mammals were free to evolve and diversify into new ecological niches. They began to occupy roles that had been dominated by dinosaurs, from small insectivores to larger herbivores and even predators. Over millions of years they gave rise to a stunning array of creatures, from tiny bats to massive whales, from swift predators to gentle grazers. This incredible diversification laid the foundation for the rich tapestry of mammalian life we see today. The extinction of the dinosaurs had cleared the path for the rise of the mammals, setting the stage for the next chapter in Earth's evolutionary saga. This new era would see the emergence of some of the most remarkable and diverse forms of life ever to inhabit our planet, ultimately leading to the rise of humans and the world we know today. The extinction of the dinosaurs marked a dramatic turning point in Earth's history, ushering in what is known as the Age of Mammals. This cataclysmic event, caused by a massive asteroid impact, wiped out nearly 75% of Earth's species, including the dominant dinosaurs, and paved the way for a new era of life to emerge. Freed from the constraints of their former reptilian overlords, mammals experienced a remarkable period of adaptive radiation. This evolutionary burst saw them evolving into a dazzling array of forms to fill the vacant ecological niches left by the dinosaurs. From tiny, shrew-like creatures to larger, more complex forms, mammals began to explore every possible habitat. This period, known as the Cenozoic era, spans from 66 million years ago to the present day. It witnessed the rise of the lineages that would eventually lead to our own species, Homo sapiens. The Cenozoic is often referred to as the Age of Mammals, because of the significant evolutionary advancements and diversification that occurred during this time. The early Cenozoic was a time of rapid change and experimentation for mammals. As the planet's climate and landscapes transformed, so too did the mammals, adapting to new environments and opportunities. This era was marked by a dynamic interplay between evolving species and shifting ecosystems. With dinosaurs out of the picture, mammals were free to grow larger, diversify their diets, and explore new habitats. This newfound freedom allowed them to occupy ecological roles that were previously dominated by dinosaurs, leading to an explosion of diversity and complexity in mammalian life. The fossil record from this period reveals a fascinating cast of characters, showcasing the remarkable evolutionary pathways that mammals embarked upon. Paleontologists have uncovered a treasure trove of fossils that provide insights into the lives of these early mammals, from their physical characteristics to their behaviors and interactions. One group of mammals, the pantodonts, evolved into large herbivorous forms, taking over the roles once filled by dinosaurs like Triceratops. These massive plant eaters roamed the ancient landscapes, shaping the vegetation and ecosystems around them. Another group, the creodonts, evolved into fearsome predators, filling the ecological void left by Tyrannosaurus rex and its kin. These carnivorous mammals were the top predators of their time, hunting and scavenging across the prehistoric world. Still, other mammals took to the trees, giving rise to the first primates, a lineage that would eventually lead to us. These early primates developed adaptations for arboreal life such as grasping hands and feet, which would prove crucial for their survival and evolution. This diversification of mammals was fueled by a number of factors. The interplay of environmental changes, availability of new resources, and evolutionary innovations all contributed to the rapid expansion and adaptation of mammalian species. The warmer climate of the early Cenozoic provided ample food and favorable conditions for growth and reproduction. Lush forests and abundant plant life created a thriving environment for herbivorous mammals, while predators found plenty of prey to sustain them. The fragmentation of continents, a result of the ongoing process of plate tectonics, created isolated landmasses that fostered unique evolutionary pathways. These isolated environments allowed mammals to evolve independently, leading to a rich diversity of species with unique adaptations. And the evolution of flowering plants, or angiosperms, provided a new and abundant source of food for many mammal species. The spread of these plants transformed ecosystems, offering new opportunities for mammals to exploit and thrive. The age of mammals was not without its challenges. Volcanic eruptions, climate fluctuations, and other natural disasters periodically disrupted ecosystems, forcing mammals to adapt or perish. These challenges played a crucial role in shaping the course of mammalian evolution. Climate fluctuations, volcanic activity, and competition among species all played a role in shaping the course of mammalian evolution. These pressures drove the development of new adaptations and strategies for survival, leading to the incredible diversity of mammals we see today. Yet, through it all, mammals flourished, diversifying into the vast array of species we see today. From the smallest shrews to the largest whales, mammals have demonstrated remarkable adaptability and evolutionary success, a testament to their resilience and ingenuity in the face of ever-changing environments.